In this first problem here, we're given a truth table and we're asked to write a max term expression for this truth table. And so one of the things that we want to remember is that for a max term expression, we want to think zeros. So if we think zeros, this will help us generate the correct max term expression. So the first way we think zeros is we look at the output column here. And we say, well, each of these outputs that are zero are going to become a max term in our expression. And so if we want to give them their short name, we can go ahead and say this is row 0, row 1, and then here's row 2. So it's capital M subscript 2, capital M subscript 3, 4, 5, and then we have M6 and M7. So the short form would say that this is M2 and M3 and M6 and M7. But we want the expanded form of this. And the expanded form of this is going to be an OR term for each of these for each of these max terms. It's going to be an OR term that has each of the literals X, Y, and Z in it. And then all of those OR terms will be ANDed together. So a nice shortcut that I can do here is just generate these OR terms. So a nice shortcut we can have here is this: generate these OR terms without any inversions on them. So this is going to be X or Y or Z. The next step we're going to do here is going to take these min terms and write an OR term for each of these. So X or Y or Z, X or Y or Z, X or Y or Z, just like that. And now here's the second point where we think zeros. So for each row that we have that's a max term, I want to make sure that each of my inputs are 0. And if they're not, I have to invert it so that it is. And so if I have 0, 1, 0 coming in, I have a 0 for X, a 0 for Z, but I have a 1 for Y. So I need to invert that 1. What will that do for us? Well, that will ensure that when 0, 1, 0 is the input, this OR term is 0. And once that OR term is 0, that ANDed with anything else is going to give an output of 0. And so then we have an output here that is 0. So then I do the same thing for the next min term. So it's 0, 1, 1. So Y and Z need to be inverted. And then 1, 1, 0. So X and Y need to be inverted. And then 1, 1, 1. So all three need to be inverted. And that's how we generate the expanded max term expression for this truth table. Problem 2. Here we're given a product of sums structure for our Boolean expression. And so we have a sum term, X or Y bar, and another sum term, X or Y or Z bar. And then those terms are ANDed together. So that's the product part. So product of sums. We want to draw a circuit and build a truth table for this. So I'm going to draw the circuit first, and then we'll build that truth table. So for product of sums form, we have first a input slash inverter area. And then we have the second thing we do is make our terms. Our terms are OR terms. So we have an OR section, and then we have our final AND section. So for the input inverter area, to make this easy, I'm just going to create the inputs and the inversions for all of the literals. And so I have X, and I also have X bar. And I'm going to make a rail that kind of goes down like that. So I have Y, and I have Y bar, and I have Z, and I have Z bar. And I'll extend these down a little bit further. All right, so for the OR section, we want to make an OR gate that can handle these two inputs, X or Y bar. So I will put an OR gate. I'm going to draw it so that's underneath my NOT gates here, so I can just draw right to those rails. And so right here would be a good spot. So I'm going to pull X and just pull it into the input. And then I have Y bar, just pull that right there. into the input. And there's one of my OR terms. The other OR term is the 3-input OR term, but I'm going to use 2 input gates only. So I'm going to take one 2-input gate and cascade it into a second 2-input OR gate, like so. And that will give me my 3 inputs, 1, 2, and 3. So the first one is X. So I will connect that input right there. And then the next one is Y. And the third one is Z bar. So this is like a 3-input OR gate. So if we had the question, why is that an OR? How is that an OR? Well, we have 2 terms that need to be ORed together, X or Y bar. That's taken care of by this gate. And then we need this term, X or Y or Z bar. So we have X or Y or Z bar. That's like a 3-input OR using 2 input gates. Then the last thing we need to do is AND these together. There are only 2 terms, so I can use the 2-input AND gate to do that. So I'll put the output of the first OR gate, that's the first term. And then I'll put the output of the second OR gate into that, that's the second term. And then this complete output here is RF. So that is a very nice way to draw the circuit, very easy to read. And we can see that it's section by section and ORs and inverters.
If it was a midterm instead of a max term, would you just invert that AND in the OR?
So if it were a min term here instead of a max term, then the AND section would be in the middle and the OR section would be at the end. Yeah, great question. So let's go ahead and build a truth table for this. And so I'm going to put it down here in this corner. So we have X, Y, Z, F. And I like to use the technique where we just have the space that we have. And we do that. We can do that enough until we get our 8 rows. It looks pretty nice. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Builds up all the rows of our truth table. So we're trying to find out what F is. We weren't given that information. And so let's take a look at our expression and then what F is from that expression. Okay. So this is a POS expression. And so like max terms, we're going to think zeros. And so we know that this is a max term right here because it has all of the literals there. So this will correspond to 1 row, and then this will correspond to 2 rows. If I think zeros, to make this set of zeros, I need X to be a 0, Y to be a 0, and Z to be a 1. So this identifies the row of inputs that is necessary to make this a 0. So I identify that in my truth table, 0, 0, 1, that's this row. And here's the place where a lot of students make mistakes. They put the F as a 1. But remember, we're thinking zeros here, so that output is a 0. Why is that the case? Well, because if I have this whole OR term being a 0, that ANDed with anything else is still going to be a 0. So that's how we do this. Now, we're looking for 2 rows here for X or Y bar. For these to be zeros, X would be a 0 and Y bar would be a 1. Or sorry, Y would be a 1, so that Y bar would be a 0. So anywhere where X is 0 and Y is 1, the output should be 0. And so going back to the truth table, where X is 0 and Y is 1, the output should be 0. So X is 0 in these 4 first ones, Y is 1 right here. And so those 2 places will be 0. And if any other location hasn't been identified by our max terms or our sum terms, then the output is going to be 1. So this finishes up that truth table. And there it is, 1, 0, 0, 0, 1, 1, 1, 1. Okay.